Okay, this is the back of the book problem 6.2, which is comparable to your 6.1. It's asking us to state the number of electrons that must be gained by atoms of each of the following to achieve a stable electron configuration. So let's review what it means to have a stable electron configuration. So we want to look at the octet rule. And that tells us that every element wants 8 electrons in their valence shell, with the exception of those that can have 2, like hydrogen and helium, and lithium, and beryllium. So we're looking at chlorine, and if we come over here, here's chlorine. Chlorine is in group 7A, and that tells us that chlorine has 7 valence electrons. So let's draw chlorine's. Here's chlorine's inner shell with 2. And then here's chlorine's outer shell with 7. 4, 5, 6, 7. So chlorine just needs how many electrons to have a full valence shell? Well, it has 7 electrons. So how many electrons does it need? It just needs 1 electron to have a full valence. And that's why we often see chlorine written as an ion like this, Cl-, because it's gained an electron in order to be stable. So for our first problem, for A, chlorine needs 1 electron to be stable. Okay, let's look at selenium. Selenium is 1 group over, right here. Selenium is in group 6, which means it has 6 electrons in its valence shell. Selenium wants how many electrons? Like all elements, selenium wants 8 electrons. It has 6 electrons in its outer shell, so it needs 2. Nitrogen is in group 5, and that tells us that it has 5 electrons in its valence shell. So in order to get 8 electrons, it needs to get 3 electrons. Iodine is like chlorine. It's in group 7, which means it has 7 electrons in its outer shell. So it just needs 1 electron to meet its octet. And then sulfur is in the same group as selenium, group 6. That means sulfur has 6 valence electrons. And so sulfur only needs 2 electrons to have a full octet.